Alright, here we are again. This time we have Cameo. He may or may not stay. So we have no daily quiz, we got nothing like that. Instead, we're just going to roll ahead with a lesson, same as if I'm there. Only difference is, instead of me waiting for you to do a thing and us coming around, when I say pause, you do the thing. When you're done doing the thing, then don't you dare touch my camera. When you're done doing the thing, then you press play and I'm here with the answers. In between, I got an awkward 3 to 4 second pause. Hopefully you actually did the thing you were supposed to do. Beyond that, same as any other class, if you would please, crack open your notebooks, your packets. 3-5, page, what's that, 107? Yeah, 107. Okay, open that up. We're going to talk about this, this front page here. Do you hear the chicken nuggets? Yeah. Yeah, Mom's got chicken nuggets out there. Okay, so I'm going to leave that just kind of sitting off to the side here. And that's just the page I'm talking about. I didn't have it printed out, so I got to kind of do it right here. In case you're wondering, this is just kind of my stream setup where, see, right? It's just my little corner. There's Baby Bear. So we're just going to wing it like that. Come on, you. Get back over there. There we go. And beginning with, we've seen these graphs, I think we saw them once or twice when we were talking about graphing by table. They're called quadratics. Anything that's a quadratic is something that has an x squared in it. So it could have something more than that. It could have 5x squared minus 19x plus 36. It could be a bunch of stuff, but the key component is it's going to have a variable that has an exponent on it, and that exponent, the biggest one that you'll see, is a 2. This type of equation, okay, if you remember all of our perfect squares when we simplified radicals, square numbers get really big really fast. So instead of steadily going up like a line, as my x's get bigger, it's going to get bigger, 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 and shoot off into the wild blue yonder. Right? So the graph of it is, the graph of a quadratic is a parabola. And it looky like a big old U. Okay? So it's going to have some features. If I have a graph that looks like this, the very bottom of the graph is called a vertex. Sometimes it can go like this. This is also a vertex. The difference is one of them is the lowest the graph ever goes. So it's called a minimum. This is the highest the graph ever goes, so it's called a maximum. Okay. Additionally, we got a little bit of vocab here for you. This is kind of headed into the second half of Algebra 1. Well, if you think it's boring, then go play with your trucks. Okay. Little bit of vocab for you here. Whenever it hits the x-axis here, or here, or here, or here. Dude, leave my cards alone. Leave the cards alone. Leave the cards alone. Nope, 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 nope. Whenever it hits those, the x-axis, we already know Y-Intercepts. Well, then let's go get you some food. We'll be back. Let's try that again. We've already been dealing with Y-intercepts with all of our lines that we've been graphing. Y-intercept is where it hits the x, or the y-axis. These are called X-intercepts. Oh, a little off to the side there. They're called X-intercepts, but they also have different names that some books and teachers are going to use interchangeably. We use these terms a lot in the upper level maths, An X-intercept is when it hits the x-axis, and when it hits the x-axis, the y is a 0. So sometimes we call these zeros. When I solve an equation, no matter what it looks like, I usually set it equal to 0 to solve. So we also call these solutions. And later when you do some really funky stuff with them, they're called roots. Okay, so these X-intercepts got a bunch of different names. What we're going to focus on today is solutions. Since this hits the x-axis twice, I'll say that it has two solutions. Okay, so we'll look over here, and the three examples they give us, there we go, those three examples are right here. Y equals x squared looks like this. And this one would have a minimum, and it only hits the x-axis once, so I'll say there's one solution. This one, on the other hand, we're going to have to go by, what do I got room for? I'm going to have to go by 2's, and every one of these is 2, so 2, 4, 6, 8, 10, 12, 14, 16. This graph is going to be way down here. I'm going to go 1, 1, 3. So there's 2, 3. I got to get my scale right here. 3, 9, 2, 4, 6, 8, 9, and 16. Very baby bear kind of flummoxed me there. And get this big, wide mamma jamma because my scale is all off and I missed one of my points. But you get the idea, it's right there on your paper. This thing, it has a minimum too, the lowest point on the graph, and it hits the x-axis in two spots. So I'll say there's two solutions, and those two solutions happen to be at, well, I completely got that wrong now because I didn't realize this. I had a bunch of extra marks in there. We'll say it's going by ones. At 4 and -4. I didn't realize I put those marks there. It's been a week. So a minimum, and it's got two solutions, and wherever it crosses the x-axis, you call those your solutions. Same thing here, except now, when I graph this guy, now it has a maximum, and you see it never hits the x-axis. So I will say this has no real solutions. Okay, so it's just, does it have a top of the hill or a bottom of the hill is a maximum or minimum, and wherever it hits the x-axis, that's called a solution. So what we're mainly doing here is practicing how do I graph them. Okay, so flip it over, and like always, it has one of these worked out for us. So that's your starting point. We're going to graph by table. So if you need to right now, pause. Everyone make sure that you have a calculator that has parentheses on it. Okay, so parentheses, I should be able to put in 2 parentheses, a number parentheses squared. Pause and make sure everyone's got a calculator that can do that. Okay, so another thing you're going to notice about these, and I'm not sure if we have it in our book yet or not, is they're going to switch to what's called function notation. Okay, so we're now working on this. That is here. This is that. Okay, it's just on my paper instead. They switched the table over to say, instead of x and y, x and f of x. So if we don't remember what that means, you saw it last year for sure. This is called a function notation. This isn't f times x, and I know that's kind of contradictory. We've always seen if I got something smashed up on parentheses, like rabbits and hormonal teenagers, they're multiplying. Well, this is not a variable. This is the name of the function. The name of the function. This tells me my input to the function, and then it gives me a rule. Okay, so this will be an expression, and it tells me if this is x, this is a bunch of stuff with x. If I say find f of 5, put a 5 into the rule, and when I do that, I'll get out a y, which is my output. You may remember seeing something like the function machine. So in this case, I'm saying 2x squared. That's my rule. F is the name of the function. Okay. Here's Frank. Okay. The machine's name is Frank. F for Frank. What it's going to do is take an input, throw it into the machine. So it's going to square stuff and then multiply by 2. And it'll spit out a y. So we've seen this before, way back when, but the idea behind function notation is it's a more technical, correct way to show you what an equation does. I like the function machine analogy because it's that idea of, look, this is the chicken nugget machine. Take a chicken, throw it in, spits out chicken nuggets. Okay? Like that is its purpose. So what they give us is -2, -1, 0, 1, 2. I didn't make my lines big enough. We're going to throw those things into this machine. That's what we do when we graph by table. So I'm going to say 2, come on you, 2 things squared, 2 things squared, 2 things squared. And this is why you need a calculator that has both parentheses and exponents on them. And you have to know how they work. If you got to pause and make sure that everyone knows how they work, go for it. So 2x squared. You see, they don't give you this room on this table. They expect that you just know how to do this. So if you need some scratch paper to do it, that's fine. Otherwise, I'm cool with you doing it all on the calculator. If I plug in a -2, this is why we use parentheses. I hope that you can see that on the board there. If I take -2 squared and I don't use parentheses, it tells me, there we go, -4. Because remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, parentheses come before exponents. Exponents come before multiplication. So this just took 2 squared, because exponents first, and then multiplied it by a -1. Well, we know that when I square a -2, when I take -2 times -2, it should be a +4. That's why we need a parenthesis around stuff when we square it, because that says take the negative times a 2, then square it. Okay? So please make sure that you have the right things. You can just dump this in your calculator and get 4 by 2 is 8. Dump in -1, 0, 1, 2, getting -1 squared is 1, 1 times 2 is 2. 0 squared is 0, times 2 is still 0. 1 squared is 1, times 2 is 2. 2 squared is 4, times 2 is 8. So you go ahead and fill out that table with 8, 2, 0, 2, 8, and then plot your points. Okay, we're going to have points at 0, 0, negative 2, 8. So I'm going to go back to up 1, 2, 3, 4, 5, 6, 7, 8. Going to go back 1 up 2. Going to go right 1 up 2. Going to go left 2 up 8. And then I connect it. Now what I don't want to do is make it a V. Okay? It's not a skinny mini. Okay? No Amanda Seyfried, you know, eat some potatoes, girl. This thing needs to have a curve to it. Okay? Beyonce style. We want a curve to it at the bottom, but actually hit your points. It's always on the right side. I missed the points. Okay? And that's your parabola. That's your big U looking thing. So you need to have a calculator. You're going to use the calculator to do this work. You don't have to show this middle step if you don't want to. If you're using a calculator that has parentheses, you can just fill in the table with those values and then plot points. Connect the dots, make it curvy. That's a short version. We're just going to keep practicing it. Okay. Come on, you. Come on, you. There you are. So we head down to example 2. Okay, so now we're going to talk about those words again. In this one, I have, what's that? 8 at negative 8, 2, negative 2, 3, 10, poke, poke. I should have actually put that graph on there beforehand, huh? Okay. It's not terrible. It works. This one, they're asking us about all of that vocabulary we just said. Are there any zeros? Okay, zeros are solutions. Solutions are X-intercepts. Are zeros. They're all interchangeable. They're talking about it in a different context. Kind of like if I was, okay, baby bear that was just here. If I call him Connor, okay, I'm addressing him directly. If I say my spawn, well, he probably did something silly. If I say goblins, okay, well, he's not making me mad, but they're definitely rambunctious. Each of those just refers to the same person in a different context. Zeros, solutions, X-intercepts, roots all refer to the same thing where it crosses the x-axis. So this time they're saying identify the zeros. So I just say where it crosses the x-axis. Negative 2 and 2. There are 2 zeros. But the zeros are also called solutions, are also called x-intercepts, are also called roots. Okay? Since this parabola opens upward, meaning the mouth of the U is opening upward, then this is a minimum. Because it's the lowest value that the y's ever go to. The lowest value it ever hits is negative 8. And it happens when x is 0. X is 0, y is negative 8. 0, negative 8 is that point. So I say there's a minimum of negative 8 at x is 0. And then later we're going to start abbreviating that. We'll say minimum negative 8 at x is 0. Okay? So the two things that we're really talking about here, and that really is it, is zeros and maximums and minimums. Beyond that, you are just graphing by table, and you're going to let the calculator do all the heavy lifting for you. So, I'll show you one more time. Go on to the next page. You should be on 109 right now. And just like we usually do, what I'm going to do is these two. I'm going to do number 1 and 3, and then you're going to pause it and set loose on 2 and 4. So they say to use the numbers negative 4, negative 3, 0, 3, 4 in this equation, x squared minus 9. Okay, you get your calculator ready, and we'll go negative, all right, clear, parenthesis, -4 parentheses squared minus 9. Let the calculator do the work for you. Parenthesis, -3 parentheses squared minus 9. Okay, parenthesis, 0 parentheses squared minus 9. Let the calculator do the heavy lifting for you. And plug in 7, 0, -9, 0, 7. Okay, it's going to be symmetric. We're not moving the parabola left to right in this section. We're just, baby steps. Take those points and plot them. Now, what you got to be careful about, you notice the scale is going to be different. So you got to remember that when you're plotting your points. So we're going to have -4, -7. 2, 4, 6, 7 is halfway through. It's supposed to be a +7. Never mind, that doesn't exist. It's really been a week. Back 3, no up or down. So we'll go left 3, 0. 0, -9 is halfway through the box. 3, 0, 4, 7. Okay, and I'm just going to put a couple more points in here because 1, 2, 3. It's going to make my graph a little bit better. Okay, so poke and poke. Connect the dots. Try to keep it curvy and actually hit the point. See, I always screw up on the right side. Okay, on number 3, they give me the graph. The graph goes all the way down to -24, hits at ±3, and it does thing, okay? What they want us to do this time is just tell me how many solutions or zeros are there. Well, there's 2 of them. There's 2 zeros. Remember, zeros are X-intercepts. They are at x equals 3 and x equals -3, because he's back. Back again. No, leave my caps alone. Leave my caps alone. No, that one. Okay. And we're going to have a minimum of -24 at x is 0, because that's the lowest point, the lowest y, and the lowest y happens when x is 0. So you just write those in the blanks and you're good to go. So if you would please, pause it. I want you to do 2 and 4. Talk with your neighbors, okay? Talk with the ladies in the room, make sure that you got it, and then hit play and I'll be here with some answers. You really don't need to see my taxes from 2017. Why are you in there? Okay. Well, we have -3, -2, 0, 2, 3. You plug those into -x² plus 4. Make sure you're using your parentheses. Oh, I suppose I should zoom in on this, right? Number 2. I'll have 4. What's that? 2, -4, 0, 0, 3, 9, -9, -5. Plot your points at 0, 4. At ±2, we're going to have our zeros. At ±3, we'll be way down here at 5. Connect the dots, keep it curvy. And there you go. on number 4, let's scroll down a little bit here. It's a skinny mini. You don't even see any other points. Just super tall and skinny like that. But I still have enough to tell you all of this stuff about it. There are 2 zeros. They are at 1 and -1. I also have a maximum, because it's the highest that the graph ever goes in terms of y's, of 4, and it happens when I'm at x equals 0. There you go. Okay, so that's the idea behind it. We're just going to do a little more practice, and hopefully you'll be good to go. So, on to the next page, that step-by-step practice box. Okay, we're going to go to that one. You don't need to go in there either. See that evil grin, you little stinker. You're just showing off for them, aren't you? All right. Number 5 has, again, here's my problem. Here's my table. Now, they didn't give me room to write it out, but I'm going to show you. If you write it out, you put a parenthesis every time there is an x. Okay, you don't need the calculator to do this. It just makes it easier. They give me the x values to try. Ha ha ha, you're so funny. And everywhere that there was an x, I'm going to put in -2, -1, 0, 1, and 2, respectively. You grab your calculator. Whoop. And in there goes -2 parenthesis, -2 parenthesis squared minus 4. Okay, type them just like that. You don't need that either. Okay, you're a little goblin. This is why we call them goblins. They rummage through things like goblins. Getting -12. Getting -1 squared is 1. 1 times -2 is -2. -2 minus 4 is -6. Is -4 is -6 is -12. Plot your points. Okay. -2, -12. You notice your scale is going by 2's again. Be careful with it. Okay, we'll get right in on that graph. Well, it's going by 2's. Be careful when you're counting. At -1, -6, 0, -4, 1, -6, 2, -12, and you can see that curve to it. Okay. What else? So 1, 2, 3, 9, 2, 4, right? 9, 18, -22. Yeah, that's already off the map. Just double checking if I can fit another point on there. Hey, that was really good. Go me. Stay out of there. Hey. You don't need to be in there. Here. You want to play with Master Uguay? Yeah? You want to play with Master Uguay? Got this little D&D turtle shaman thing that he's in love with. Do it again. Except this time you're in charge. You're going to pause and do numbers 6 through 9. Okay? 6, 7, 8, 9. I want you to pause and do all the stuff. I'm also going to pause and deal with this, and then we'll go through it together. But you don't hit play until you are done with those 4 problems. Go. Okay. Start with 6. Again, you're plugging in to your calculator -4 parenthesis thing squared, just like that. Fill in the table, get your points. Now that you have your points, you plot back 2 down 16. Watch your scale. Okay, watch your scale. Back 1 down 4, 0, 0, 1, 4, 2, 16. I know those shakies are awesome, right? And we connect the dots. Okay? On 7, again, you have to be very careful with your scale. Look at what they're doing. Each box is worth 4. So, parenthesis, number, squared, minus 16. If you're doing these on the bumblebees, the graphing calculators, make sure that when you use this, there is a difference between the negative button and minus. Those are very different. I know, buddy. I know. Okay, we're going to take care of this. You want to play with tape? You play with tape. Just be careful that you know the difference between negatives and minus on the calculator. Be careful with your scale going by 4s. We're going to be at 0, negative 16. So you're going to rage throw things at me. Going to be at 4, 0, negative 4, 0. 5, 9. So this is 4, 8, and just a little bit above it, 1/4 above it, is the next one. Now I'm going to put some more points on here because I need that to make my graph a little bit better, but it's going to be at 1 above, going to be at 4 above, going to be at 9 above, poke, poke. Okay, so I needed a few more points or else my graph's just going to be terrible, but you should be able to ballpark yours just with those 5 points, and that's okay. All right, so that's all there is to it. Same with 8 and 9. There you go, you got numbers. Are they the right numbers? Plot points. 0, 3, watch your scale, going by 2s. 1, 5, negative 1, 5. 2, 11, negative 2, 11. Connect the dots. Now I know it didn't ask for it, but how many zeros does this have? None. I would say no real zeros. There are no real zeros because this thing never actually hits the x-axis. If I ask, does it have a maximum or a minimum? There's a minimum of 2 at x equals 0. Okay. Down here, same thing. Plug it in there. If you need to use a fraction, okay, negative fraction box. To get the fraction box on, he's trying to steal his brother's food. If you need the fraction box, it's alpha y equals. Alpha is the green button, and top left corner is y equals, and then that'll get you your fraction menu. Okay, so if I do that, -1 half parenthesis, -4 parenthesis squared minus 6. Okay, you type them out like that. So we're going to have 0, -6, and they're going by 4s on this one. So again, careful with your scale. Like, that's the biggest problem here. At 2, -10, so again, halfway through the box, at plus or minus 2. 4, -14, again, halfway through the box. And this one's just going to be nice and wide. don't try to make a V out of it, because I know it looks an awful lot like a V when you have it in this scale. Okay, please don't. There is a curve to it. Okay, make sure there's a curve. And then the very, very last thing is, you know it, you have it every time. Words! But how many times are our word problems just blah, 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 do what you just did, right? So in this case, you have an object dropped from a window, whoop, and its height, h, is going to be modeled by how long it was falling, and that's t for time. This is a very, very common type of problem. Falling objects can actually be modeled with a specific type of quadratic. It's called a vertical motion model. Height in terms of time is negative 16t squared, because the pull of gravity is constant, plus my initial velocity, they call it v sub 0, times time, plus my initial height times time. Oh, but the time will be 0 because it's my initial height. Okay. You don't have to write it down. I'm just saying this is something that crops up in Algebra 1, and then you use it for the rest of high school. So that's where they made the equation from. All you care about is they said, hey, look, words. Words can make equation. Equation can get graphed. So do what you did before. Get your parenthesis on. Negative 9, parentheses, 0 squared, plus 36. I think by now we're getting the idea that that's just going to be whatever this constant term is. Put in a 2. 2 squared is 4. 4 times negative 9 is negative 36. Negative 36 plus 6 is 0. And the same thing will happen over here if you're using your parentheses. I'll get 9 times negative 9 is negative 81, big mamma jamma, plus 36, and I am so tired I can't do basic arithmetic. Never be ashamed of using the calculator. Okay, negative 9 parenthesis 3 parenthesis squared plus 36. Negative 45, there you go. Okay, proof. So those are going to be at negative 45, negative 45. So look at that honkin' scale. Okay, the scale of your graph is going by 10, so you're going to have to ballpark this. At 0, 36, imagine 6 or 10 little dots in between there. At 2, 0, okay, that one I can do. Negative 2, 0. 3, negative 45. So here's 10, 20, 30, 40, 5. Here's 10, 20, 30, 40, 5. Connect the dots. Try to keep it curvy. There we go. All right. That's it. So what, 40 minutes in? 40 minutes of lesson stuff. I'm sure you had to pause and do stuff, so you're probably at about an hour or so, which means if you did this right, if everyone was on their game, you should be sitting at about 20, 30 minutes left. And I'm not going to see you again until Monday. So you have until Monday to finish it off. Okay? Starting here on page 111, you're going to do number 11 through 19. Hit the stop sign and you're done. So you have a grand total of 6 of these that you have to graph. You might even be able to get it done right now, if not in Spartan time. If you have any questions, hit me up on Remind. Otherwise, I hope to see you all on Monday. Oh, and while I'm thinking of it, go over to the board and mark down your choices for Pi Day, because Mama Bear's on the mend, and she is adamant that we are still going to do Pi Day. So, see y'all Monday.